Assalamualaikum and welcome to our mini project presentation for EMM3118. In this video, we will analyze the dynamic of a single cylinder piston system. Hi, my name is Saripah Hafiza binti Abdul Halim and my metric number is 230540. The introduction. A piston is a key component in a reciprocating engine. It's made from a cylindrical piece of metal with piston rings that help to form an airtight seal once the piston is installed within the engine cylinder. The piston is attached via a piston pin to a connecting rod, which in turn is connected to the crankshaft. The piston system is a fundamental part of engine, converting linear motion into rotational motion. This project focused on the analysis of the dynamic of a piston system, incorporating principle of sustainable design in alignment with SDG, particularly in SDG 9 and SDG 13. The goal of this project is to determine the derivative of the kinematic equation that describe the piston motion in order to analyze the dynamic of the system while exploring improvement in energy efficiency and environmental impact. The first one is piston system. The dynamic of a piston system refers to how the piston and its connected part move and interact during engine operation. Inside the cylinder, the piston moves up and down due to pressure from combustion or compression. This linear motion is transferred through a connecting rod to rotate the crankshaft, converting it into rotational motion. Several forces act on the piston, mainly gas pressure, friction, and inertia. As the crankshaft turns, the piston position, speed, and acceleration constantly change, creating a complex motion. These changes affect how much force is transmitted and can cause vibration if not balanced properly.
I'm Akila and my metric number is 230249. Pistons play a crucial role in converting the energy from fuel combustion into mechanical work, powering everything from cars to industrial machines. A piston mechanism is a fundamental component in systems such as internal combustion engines. The dynamics of a piston involve the study of its motion kinematics and the force acting on its kinetics. We focus on kinematics of a piston. The piston undergoes reciprocating motion inside a cylinder. This motion is driven by a crankshaft and connecting rod assembly, converting rotational motion into translational motion. The piston mechanism converts energy from combustion into mechanical work, which is then transferred to the crankshaft. The equation for work done is integration of F combustion.
Assalamualaikum and hi, my name is Irfan Hilmi bin Razali and now I will explain about the crankshaft and the free body diagram of a piston. So what is a crankshaft? A crankshaft is a crucial component in the engine that turns the linear motion of a piston into a rotational motion. The rotational motion of the crankshaft then delivers torque to the drivetrain, which make the car wheel spin and able to move. So this is the crankshaft model made by Mazzer using the CATIA software. Actually, crankshaft have various shape and sizes and it is dependent on the type of engine. For this project, we choose inline 4 engine because it is the most common engine type and makes it easy for us to show how the mechanism works. This is the free body diagram of the piston. The force F shown on the piston head is generated by combustion. This force pushes the piston downward, and since the piston is connected to the crank via the connecting rod, this motion is transmitted to the crank. The connecting rod applies a torque to the crank, causing it to rotate. In short, the combustion force creates linear piston motion, which is then converted into crankshaft rotation.
My name is Mahzi Zulfaka and I will present on the equation of motion for this dynamic project. Now, we can apply the knowledge that we have learned under the topic kinematics of planar rigid body to solve for the linear velocity, angular velocity, as well as linear acceleration of the components of the piston. So the first part is the linear velocity of A and B. We can simply use the equation that we have learned, and this is the form that we are going to get. However, the most important part here is the relation between theta and phi, where we can equate them together since they are sharing the same side. So LOA sine theta is equal to L length of AB sine phi. Now, for angular velocity, we can derive it from the equation of linear velocity, and after some manipulation of the subject of the formula, this two are the equations that we are going to get. And lastly, the equation for acceleration. Again, we can directly apply from the equation that we have learned under the kinematics of planar rigid body topic.
My name is Muhammad Shafir Irfan bin Abdul Rahim. My metric number is 230237. So I will explain the angular velocity analysis for a mechanical system involving two rotating discs AB and OA. So what is the angular velocity? Angular velocity is the rate at which an object rotates about a fixed axis. So the vector ijk is the unit vector for xyz direction. So first we find the angular velocity AB. Since point B has only a y direction velocity, so VBG equals to 0. So from our previous equation velocity, we get VB equals to VA plus omega A BK times R. So we derive it to become omega A BK equals to negative VA over 0.17596 times sin theta I plus cos theta J. So for the next boost, we find angular velocity OA. Same as before, from our previous equation velocity, we get VA equals to VO times omega OA K times R OA. So we derive it to become omega OA equals to VA times VA minus VO over 0.042 times negative sin theta I plus cos theta J. The important thing is we need to know the negative or positive sign of the answer. So we know the angular velocity direction is clockwise or anti-clockwise.